Hello and welcome to a global event hosted by Kingspan. At Kingspan, we like to stay curious and ask ourselves, what if? What if the insulation spectrum could include insulation products with a thermal conductivity as low as 0.007? And what if that meant roof decks with very little space could achieve high thermal performance? Today's masterclass will look at OPTIM-R E, our encapsulated vacuum insulation panel. We understand that you might be curious as well and have questions. And if you do have questions, please do email them over to our email address and we will have time for questions after the presentation. If we don't get time for all of the questions at the end, we will get back to you after today's event. I'll now hand over to Matt, who will talk you through OPTIM-R E.
Hello there. So it's been a great day. Really enjoyed the presentation so far. So looking forward to going through my presentation. So I'm Matt Evans. I work for Kingspan Insulation. Look after the Great Britain market. Based over in England, I live locally near our Pembridge plant. So the way this presentation is going to go, I'm going to talk a little bit about what vacuum insulated panels are and where they kind of come from. Then I'm going to talk about the recent innovation that we've done, OPTIM-R E, which Lucy just kind of outlined a little bit, which is a spray-coated vacuum insulated panel. And then I'm going to talk about the lovely world of inverted roofs. So we'll do a little bit talking about what they are and how this product is being used in that application. So let's crack on. So it's worth just thinking about where vacuum insulated panels started from. So in 1892, the vacuum flask was invented. And believe it or not, that's where the principle to vacuum insulated panels kind of originate from. So from that period, if you think moving on a little bit, in 1970, that's when vacuum insulated panels were used in commercial appliances, fridges, freezers, shipping cold storage containers. So, I mean, that's going back to 1970s. Then in 1999, in the US government for housing and urban development kind of did a 3-year kind of study. And that kind of report kind of outlined that VIP panels can be a feasible and important kind of option for achieve energy and efficiency in buildings. So that was going back to 2000 in the US, which they have, to be fair, that market, VIP panels are very well known. In Europe, in 2005, started to become a bit more popular. So you've got, I think they were used in Germany, Switzerland, Scandinavia. That's where you started to see it a bit more in construction and this kind of Europe. Then when did Kingspan get involved? Well, 2012, we launched the OPTIM-R panel. That was our first kind of step to actually say, we're going to do vacuum panels for construction. In 2013, we had a fully commissioned production line. So that's obviously the plant that I'm based at, Pembridge. So we make them, we've been making them over 10 years ourselves. So we've had 10 years experience of working out what the vacuum panel is, what applications we can use it on. Now we're kind of looking at what developments can we make to that panel to use the more applications. So what I'm going to talk about now, I'll just move on. Just going to recap actually what is a vacuum insulated panel, because I'm always mindful that actually we just say the word vacuum insulated panel and it's just worth thinking, what is that? Well, first of all, it's a microporous core. It's kind of wrapped in a kind of fleece. And I should say a couple of slides further on, I kind of go through the manufacturing process. It's then kind of wrapped in a kind of foil envelope and an air is evacuated out of that envelope. It's then sealed. So it's, like I say, it's a vacuum insulated panel. It's not something you can cut or you can kind of puncture. So it's a very different kind of way of looking at where can this product be used in construction. And as I go through a few slides in a minute, I'll talk about the design service and how we make that kind of work. But importantly, as kind of Lucy kind of said, the thermal conductivity of 0.007 does mean it can be 3 times slimmer than our cool firm kind of lower lander kind of insulation. So where you've got height restrictions, this product is really looking at that problem-solving situation. So this is just to kind of recap what I've just kind of said, but looking at more insulation products. So If you were to look at a thermal resistance value of 5, what kind of thickness of insulation would you need? And you would need 35 mil of OPTIM-R. So what would you need with other products to achieve the same thermal performance as OPTIM-R? And you can see 95 mil in our lower lander cool film, going right up to 185 mil in glass mineral fiber insulation. So where you've got restriction in kind of heights, this could be the solution. So I'm going to show, in a few slides' time, I'm going to show like a bit of a kind of real-life example where there was a height restriction and where it was a kind of problem solver. But listen to all the slides and presentations today. You know, the climate change emergency we have in this world, insulating buildings to high performance is actually key to reducing. So just to take a step back, I work for obviously in the UK market, and the UK Climate Change Committee kind of said that they estimated direct emissions from buildings accounted for 17% of the total greenhouse emissions in the UK. So insulating buildings to reduce that could have a big impact. And I think the thing is thinking about, this isn't new build, this is refurbishment, this is existing buildings. And this is where you have the problem with trying to insulate existing buildings, where you just simply don't have the space. We're obviously seeing that building regulations are actually tightening on U values. They're wanting lower and lower U values. So not only refurb, but looking at new build. So there could be new build solutions now where you can only go so thick in certain applications. You know, you start having impact on the depth of fascias, or, you know, the type of window depths you've got. You know, you do get to a point of saying, well, how thick can you make that wall, floor, or roof construction? There does come a kind of tipping point where you're impacting the architectural look and design of a building. But also, it's worth just considering just on insulating the fabric of the building first to a high standard. If you think of heat pumps, all the kind of talk at the moment, we all support them, but they need to work harder in the winter months to be most efficient. So insulating the fabric of the building, so you're reducing the demand to actually heat that building, has got to be part of the answer, not just relying just on the heat pump to think it's going to do it all. So yeah, I'm going to move on to the next slide. So a quick kind of lesson in how we make the product. So I should say I'm more the application side. So you know, I don't make the product, but it's good kind of seeing it actually made on the line. So I'll explain it in my kind of way, I guess. So if you think of a big bag of powder, it's the best way I explain it, that goes in a big kind of mold. It could be like that in depth. That powder is then pressed to almost make a kind of solid kind of board. Okay, that's then kind of put a fleece around it that kind of helps during the processing of the product. Then goes into a kind of an oven to actually dry out any kind of remaining moisture. Then wrapped in the aluminium foil. Then it goes into a vacuum chamber. And like I said, well, that's when the air is evacuated out of the core. It's then sealed. But what we then do is those vacuum panels are then left in our warehouse for a certain amount of time. Every individual panel is then pressure tested before it's then boxed. So we know that every panel is being correctly kind of vacuumed. So there's a bit of a brief kind of overview. But it's important to note it's a bit different to like rigid insulation board where you've got a continuous production line, it's one board, you're making every single panel individually. So it's a different way of us kind of making it really. So I talked a little bit about the standard vacuum panel, and what I want to talk about now is the innovation that we've done. So we've now come up with a spray-coated vacuum panel. And you might say, well, why do you need to spray coat it? Well, if you think of being able to easily handle it, to actually install it on site, it's more robust. If we want to put it in more applications that are more, I'm going to come on to an inverted roof in a minute. If we want to come in an application where it could be more exposed to damage on site, how do we make a panel that's more robust? Because like I said before, we do give toolbox talks on how to install the vacuum insulated panel to make sure it's not damaged on site and what to look to make sure, anything to look out for. But this gives an extra level of robustness, particularly for an inverted roof, which I'll come on with. So it's got a spray coating to it. It does effectively land the value ever so slightly of 0.008. Same sizes. And this came about of £1 million kind of investment at our Pembridge plant to actually have the machinery to actually do an automated spray coating. But I think what this does allow us to do, and this is what we're getting asked for in many markets now, is extended product warranties. So we've managed to better offer a 20-year manufacturer's product warranty. But particularly in roofing, people are looking for roofing systems that are going to be given 20-year manufacturer's warranty. So it kind of allows us the confidence to say we know it's going to achieve. The manufacturing process. Now, I should say there is a great video on, I've been told, Kingspan Insulation UK YouTube, hope I got it right, that actually shows a 5-minute clip of the actual spray coating of the panel. But as you can imagine, over a kind of live over the web, we don't want to kind of run the video, but we can always post a link on it. But what it does show you is a panel, the standard vacuum panel going in. It's spray coated all the way round. And then about a minute later, it comes out. And that's when it's cured. It's dry at that point. So it's quite a quick process. So I appreciate the order pictures, but I do encourage you to go and see the video because it does actually really kind of show it live in action with a robotic arm going right the way around the panel and spraying it. But so it was quite a big an investment at our Pembridge plant to be able to do that. But the reason why it's automated gives us continuous quality of how much spray, what thickness we're applying to that kind of vacuum panel. So we've got very tight tolerances and controls. So it's why it is a automated kind of system. So we're going to talk a bit about inverted roofs in a minute. So just to recap where we've done then. So we talked about the vacuum panel where it started, talked about a spray-coated version of it, okay, which we've now got. I'm now really going to move into where can it be used, what real-life applications. So my background, I used to work in a builder's merchant. I'm used to installing products. So this is what we're going to talk about now, is actually where it can go. So inverted roofing, there's different finishes. So it's traditionally kind of like terraces, that type of thing, balconies, where you might have paving slabs, gravel ballast, a green roof. These are the type of kind of finishes that you would kind of see. So I'm going to give you a little bit of a list of the build-up now. So when I started technical, many years ago now, I'm starting to realize it's a few years now, we used to call it an upside-down roof, which is quite an old phrase. You don't hear that so much now, but really it basically means, as in inverted, the waterproofing goes down on the concrete deck first. So you've got your flat concrete deck, you waterproof it first. Then the insulation goes on top. There's a filtration or infiltration water reduction kind of membrane that would go on top, and then the paving slabs. But this is a completely loose laid system. So there's no adhesive, it's all loose laid. The ballast, as in the paving slabs, and this one, or is in gravel ballast, is holding all that roof down. And what it does allow is that water can go through right down to the waterproofing and back out, a complete freeze-fall kind of drying cycle. So, and what you'll find is that water will drain on top of the infiltration, kind of filtration membrane, and a small amount might get through to the waterproofing, and that's kind of drained away as well. But you might say, why do people do that? Well, it's like any flat roof. There's always the right design for the right roof, and certain warm roofs are going to be better situated than others, really. But inverted roofs, what it does do is that because you've got the waterproofing membrane below the insulation, you are protecting it from damage. So if you think of storm damage, kind of external, kind of extreme weather conditions, damage when they're maintaining plant equipment on top of, for example. So there's always types of benefits. Also, you can waterproof the structure quicker if you've got a flat roof deck and the insulation may not be going out until later. It does allow you to waterproof it. But also, I think one of the key ones, it's used for where there's trafficked roofs, where there's going to be a certain amount of loadings on there. There's going to be people walking on there. So you want a robust kind of roofing system. So traditionally, you would use an XPS or an EPS. So we do the Kingspan Green Guard. So that's what traditionally is being used. Thermal conductivity of XPS, I mean, Kingspan's Green Guard is 0.034. So it's like anything, there's a trade-off. There's a thicker construction. So I thought, as I going back to my practical background, I'd show you an example project. Okay, so this was a project in London, domestic kind of balconies, terraces. This is where we're seeing a lot of the vacuum panel kind of used, where height restriction really is tight. This could be new build, by the way, or refurbishment. If you think of new build, if you could save a certain amount of thickness across 10 stories, that might give you another story on a building or something. Or, you know, there's so much more it can give you. So there was the concrete deck. So I can just imagine the call that would have come through to technical would have been, so I've got this concrete deck. I've only got 90 mil to play with. How do I insulate it? And the typical answer is, well, I tell you what, we'll put all the insulation below the deck. Let's put it on the inside of the building. Well, the problem with that is that's a cold roof. You're going to cause condensation there, unless you can ventilate between the insulation and the underside of the concrete deck, which if you've just seen all those terraces, there's no way you're going to create ventilation on every single one. You might have someone saying, well, I'll tell you what, we'll put a little bit on top and a little bit below the deck. That causes condensation problem again. So we typically with residential, humidity class level 4, internal relative humidity 60 to 70%. We would run the U-value calculation, but I would suspect that there would be a condensation risk again. But even if you could put a small amount of insulation below the deck to help, that makes it quite hard when you think of refurb. You've got to take all the ceilings down, take all the surfaces down. So sometimes a customer is kind of saying, well, I've only got so much space. If you look at that picture there, there are patio doors on that one. If you were to open that patio doors, you've only got that set number of space. You can't really do a step up because there's certain building regulations that say you need to have level thresholds. So you really are limited what you can kind of do. So having gone through the kind of talked them around into this is what we've kind of looked at, we've kind of got a solution. Possibly could we look at a vacuum insulated panel to help reduce the kind of thickness. So what we do is we do a design service. So I talked a little bit earlier about you can't cut or puncture a vacuum panel. So if you're going to use it in any application, we need to do a design service to say, where can you use the panels? Where you can't use a full panel, what do you do around the edges of the roof? What do you do around any upstands? And this is where we use an infill of our normal green guard insulation. So this drawing here, what they would have done is they would have done the whole layout and then worked out, okay, round the edge, we need a 200 mil strip of a green guard to fill those kind of gap or around any kind of upstands or any kind of openings like roof lights, things like that. We then kind of calculate that percentage to make sure we take account for how much of green guard we've used and how much of OPTIM-R E. We then do an overlay. So we put a green guard overlay just to give a continuous kind of layer that helps with then the final kind of loadings of kind of heavy traffic kind of roofs. So we do that. I should say we do site surveys. And during the install process, we do toolbox talks and site inspections to make sure that they're actually understanding how to install that kind of system. So I think so we've kind of calculated that one. So here are a real life project. So the deck was waterproofed. We then come along with the OPTIM-R E panels, which they come in a box. What I should say is normally with vacuum insulated panels, you need like a rubber crumb protection layer. So to make sure any chip-ins or anything like that don't actually damage a vacuum panel. With OPTIM-R E, don't need that. You can go straight down onto the concrete deck. They just brush it clean. and then a laid panels loose laid. So you can see, actually on this one, we had 2 layers of OPTIM-R E going down. So that's the first stage. Second stage, we've overlaid with a 30mm green guard. So this is actually a rebated kind of product. So it kind of locks it kind of together, creates like a uniform kind of final finish, to then lay the Aquazone membrane, which is a water infiltration reduction membrane. And that's a mouthful, but what it means is it actually reduces the amount of water that actually flows into the system. Some water will still get through down to the waterproofing, but it does reduce a fair amount of it. So you can see those patio doors there. That insulation is just below those patio doors. They can now lay those, the membrane and paving slabs, and that's kind of achieved the U value for refurbishment, which is 0.18. But without that solution, that wouldn't have been achievable. If I go back to the previous slides of actually the why buildings need to be insulated to a high performance, this really has been a kind of problem solver. So I talked a little bit about, that was a real life kind of project, but what we're seeing more of now, that was a refurb project. What we're seeing more of now is, what about new build? What about when you need to achieve really low U values on new build projects to meet the new kind of building regulations as they come in? And this is kind of an option as shown a U value of 0.11, which in England is a kind of the best starting point for new build. And the top option there was showing a total thickness of 130mm. 2 layers of 50mm OPTIM-R E and a 30mm overlay. The equivalent at the bottom there is 320mm, which is quite a lot of insulation. So they may be able to design that into the building, that's fine. But like I said before, we need to think about how does it impact the depth of the fascias, how does it impact the visual appearance of the building. There's lots of factors. So it's all about, if it can be designed in, it's an option, but it may not be. Next option is looking at a refurb, which is kind of just going back to the project we just did, really. And this is where 0.18. So really, we did it in 90mm, that particular option. And equivalent in a green guard was 200mm. Now, I should say every project is designed differently. You will get differences in U value. And the reason why is because if you look at the top one there, we did that in 90mm. It all depends on the bridging percentage of how many panels can we get into an area. So actually, the bigger the area, the more kind of panels we can fit in an area, and the bridging percentage of normal kind of green guard around the edges of the roof are less. But you might have a roof that's got more kind of roof lights, for example. So we calculate it every kind of project. So this is just recapping a little bit, because I talked about going the thinnest solution, but actually sometimes when you're designing a building, it's what's the most economical. OPTIM-R E is more expensive. So it's actually working out what's the optimum use of that product. So this is where we started to look at a few options. And just to recap, this was getting a U value of 0.11, the thinnest possible build-up of 2 layers of 50mm and a 30mm overlay of green guard. But actually, you might find that there is a bit more space there. Can we just try and use the maximum height? Can we take the measurement from the customer who says to us, actually, I've got 150mm. The normal insulation means I need 200, 300mm. How do I get that just to meet my 200mm? How can I be that problem solver to meet that project requirements? And that's what we've done there. We've put 50mm of OPTIM-R E with 150mm of the green guard overlay. So we've met that requirement of 200mm. So that's the most economical kind of solution. And we've done that, we're signed out more and more on projects now, where architects are saying, I've got this space, I need to hit this U value, can you give me a solution to meet that? Don't need to go thinner, just need to hit that kind of target. This was given 0.1 actually, so so I think the previous slide, I think we got 0.12. It was close to what the architect kind of wanted. Next option was actually hitting 0.1. I think the architect was after 0.11, slightly better. So we've done 2 layers of 100mm green guard here with 50mm OPTIM-R E. So just to kind of recap all the kind of what we talked about the product there. It's a new product. It's spray coated. We feel it can go into many more applications. Extended warranty, can be a problem solver and can be used for new applications. So I should say we are looking, can we use it in flooring? We use OPTIM-R today in flooring. In flat roofing, in the inverted roofing, can we do it without that overlay of green guard? Can we use it even in warm roofing, where we put a layer of PIR insulation over the top and then waterproofing on top? So I think there's more applications to come, but it's been a good new development. So I hope I've explained that kind of well, and I'm sure Lucy's going to come in and give me some questions. But I think that's
Thank you, Matt. We do have some questions.
Good.
So you mentioned on the slide behind you the design thermal conductivity as low as 0.009. How does that differ to the 0.008 that you talked about earlier on in the presentation?
Yeah, so there is a correction. We're hoping to actually come to a point where we don't need to take that. It's to do with the way you do the U-value calculation, to do with moisture. So we're hoping at the moment it's a design, so we have a declared lambda value. And we have a design which is used for the U-value calculations. But we are doing some work at the moment where hopefully we'll be able to say actually for the roofing application in that market we could do it as 0.008 is the plan.
Okay, thank you. And you mentioned the design service a few times. Is that something that you charge for?
No, it's a free of charge design service, and you do get a layout of the actual panel. So. Yeah, and what they can do is they can give you an initial kind of estimate on, before doing a full design. So we can kind of say, okay, you're after that type of U-value. We've got experience of that type of roof, it's this type of bridging. This is the kind of estimate you're looking at. We'll now go and do a detailed design. We'll do the roofing survey. And yeah.
Okay, thank you. And finally, why have you chosen flat roofing as the first application for the product?
Yeah, well, I think really, if you think of spray coating, the reason why we use it, that application is more exposed. Mm-hmm. And I think, so we wanted an extra level of protection in that application. But if you think of why using in kind of flat roofing, it's because you've got a nice kind of, fairly large kind of areas. You haven't got really windows and doors to work around. You haven't got things like wall ties for brickwork and things like that in walls. Not saying it couldn't be done, but really flat roofing lends itself quite well because it can be loose laid, hasn't got to be bonded down, hasn't got to be fixed. The key bit there is it can just be loose laid. So we haven't got to worry about how do we fix it, how do we... so it's why it lends itself really well to flat roofing and flooring. The two ones that we've seen that it works quite well on. But typically in flat roof, if you think of flat roofing, even just when you're installing part, just be more robust, just being able to, even when you're laying it, you're trying to avoid walking on it, but you do have to in certain situations. So it's just making it more robust. So flat roofing is where we've kind of seen the first step of it, really.
Okay, thank you. And thank you, Matt. And thank you to everyone at home for watching. We hope you found it interesting and useful. And as always, if you do have any questions, please do email them in and we'd be happy to answer them for you. Thank you.